All right, so let's get started. Also, welcome to NDC. Thanks to organizers for organizing such a nice event. Even if it is remote, it's kind of a bummer. Thanks in advance to my family for keeping in-house intact for the next hour. And welcome to my talk, Refactoring the Architect's Role. So a little bit about me. I'm way lesser known head springer than some dude that's going to speak later today. I have title of principal consultant. I have been involved in lots of distributed systems and microservices projects over the last few years. I've worked on a variety of different projects and different kind of finance sectors, marketing sectors, different kind of sectors of companies. And I blog at Aradhye.com. My Twitter handle is Aradhye, and that's the best way to reach out to me, but the other social media handles are also there. So this talk was really originated from my experience of converting monolithic systems to microservices project. I worked on this system on this project for more than 2.5 years. And we came into this project as consultants and started looking at this monolithic architecture here. It was it consisted of large horizontal layers. There were 55 dev teams trying to make changes to this application. There were 140 odd projects. Whenever you try to open the Visual Studio with ReSharper on, or any other extensions similar to that on, it would crash Visual Studio. It was lots of, there were frequent rollbacks of the releases. So there was a lot of chaos going on in that one solution with all these projects that were happening. As Jimmy puts it here, what monolith is multiple domains, and multiple domain concerns and interfaces are kind of mashed into one single application and one data model. Yeah, that makes sense. But then it more felt like a dumpster fire when you're trying to make a change to it, when you're trying to update it. It worked. I'm not trying to diss at it per se, but it worked in past. However, the current state was current state that we walked into was unsustainable. So then we started doing the analysis, and then we followed this process roughly where we started analyzing the domain, what the domain of the client was, how their application worked, the business side of it, then started defining the bounded context, then start figuring out the aggregates out of that, and then eventually start coming up with microservices around their business domain. So then based on that, we put out one microservice into production, and life was great. Everything was fantastic. Everything worked smoothly. Out of that, we were able to extract out the code from the giant monolithic application that we had. Everything was fantastic. But then, little that we knew, while our core team was shipping out that one service, everybody else was doing the same based on the draft that we created for our business boundaries. And everybody started pushing out and working on these microservices. The transformation, the spawn of microservices was kicking in. And we just didn't know that was happening. So the dumpster fire that we came from became more of like a floating dumpster fire now, because everybody's trying to make changes, and it started getting really complicated. There was no method to the madness of any kind. So to keep that in check, the architecture group was formed. The idea behind that was to rein in the madness. It's very hard to disagree with the initial goal here. We wanted to make sure that we're doing the right thing. We wanted to achieve. We wanted to help teams achieve their goal, bring in uniformity, and then they brought us into this team as well, as microservices consultants. But instead of started seeing improvements right away, we started running into more problems, and some symptoms started to emerge. So one of the things that we run into more frequently was the friction with the Agile Scrum Masters. So whenever we say architecture, Agile folks hear waterfall, and that made all of our meetings contentious. They were like, we lost your hello. The whole thing felt forced. We started hearing things like, oh, we're doing such a XYZ thing because architecture is telling us to do these things. And that's not what we wanted. We wanted teams to really come to a solid solution as a team, instead of saying, oh, one person or the other person or some title over there is saying something to do a certain way, and that's why we're doing it. So all of this started resulting into negative productivity. Everybody was always behind. Everybody was always catching up from architecture side of things, because there were so many things happening all over the place, many different initiatives. We're trying to go to cloud at the same time. We're trying to create platforms, tools, patterns, all these things. So it was a lot of scattered brain problems going on. We were always busy, but the productivity was not quite there as a team. We also saw that there was lack of clarity in the mission. Like, what are we trying to do? There was confusion about the role. There's not a lot of accountability. What are we supposed to do? Are we part of the team? Are we tech leads of the team? Are we tech leads of the tech leads? What is going on with our approach? And then as a result, everybody on the architecture team felt burnt out. We were having business issues. There was a question. Yeah, in the Slack channel there was a question that the presentation will be shared. So So the result of the whole thing was that we were feeling burnt out, and then the business impact was not there for our the architecture team's goal. The inefficiencies were all over the place, and then the team was very ineffective. And that floating dumpster fire really continued. And as a good consultant, we started to analyze and say, okay, let's take a step back and understand what's going on. We wanted to establish why this architecture, why do we exist? We wanted to establish that because we wanted to make sure that teams understand why architecture is important and why this team exists. Every project that you do, every software project that you have has an architecture, whether you like it or not. It will eventually choose you. So instead of that happening, what we wanted was intentional direction for our systems, so that we can have architecture of our choice instead of something accidentally that we're landing on. And then we wanted to also make sure that we're making decisions that are going to save us money, and not having to make expensive mistakes and then roll them back. And also wanted to give a lot of decent context for onboarding new engineers, because if we give a feature to develop to a new engineer and they don't have any context of why are we doing this, what are the architectural design concepts behind certain things, it gets really difficult for people to wrap their mind around, and it takes time for them to ramp up. So we wanted to cut that time down. So these books helped me a lot when I was doing the analysis. The evolutionary architecture term first came into my vocabulary from Building Microservices book, and then other books followed with that. And then Gregor Hoffa's book, he's written multiple books over the years, and this is one of my favorite books that he has written, 37 Things One Architect Knows About IT Transformation. So that helped me a lot in doing this analysis. So when we did this analysis, we decided to put this analysis into some kind of context that people could understand. And what could be better than taking the ideas from Martin Fowler and then thinking about smells and refactorings? Because as engineers, we know what the smells are and what refactorings are. These smells are essentially just those subtle inefficiencies in your code that makes things really annoying to change. And then refactoring is we're not redoing the whole thing. We're not rewriting the application. We're changing the application code incrementally, so that we are making progress, but we're not throwing everything out and then bringing the new things in. So from that perspective, let's start looking at what the smells and refactorings that we came up with based on the analysis that we did. First and foremost, there was confusion about the term architecture itself. What is the architecture? Is it pie in the sky? Are we just writing a bunch of documents? Are we doing something up front that's going to spend like 2 months on something? We're going to just draw pretty pictures or something that these people over there in Ivory Tower sit in there and they troll and do things. What is architecture? We wanted to understand that. And then there was a lot of confusion across the organization about architecture itself. There was a lot of fear, uncertainty, and doubt. So the most concise definition and most understandable definition out there is from Martin Fowler, which is shared understanding of the system. What is it that your team collectively understands? So this was a really good definition that resonated with most of us. And the second definition I personally like a lot that I read from, that I got from Gregor Hoff's book, and the original authors are at the bottom. The design decisions that really stop you from exercising needless creativity when you're trying to solve a problem. So you have a framework in place to solve your problem so that you don't have to figure out, oh, what do I do if I have a database? I have a database to choose from, and then I have to make certain queries certain way. What is the pattern? All of these things. When we are in the middle of the projects, we don't want to exercise creativity at that point. We want to concentrate on solving a business problem instead of stumbling on these technical issues as we're going forward. So design decisions are, those are the design decisions make the architecture. And that's kind of started resonating with us later on as well. But this was my favorite definition from architecture standpoint. So we started establishing that, okay, this is in our organization, this is what we want to promote. Architecture is really what makes your system easier to change. So if we're producing a change, if you're trying to change our application, how easy it is to make that change. And also we want to keep an eye on dollar amount that we're spending to make these changes, because if we put an application into EC2, let's say in AWS, or something like that, that's not going to scale very well, or if we have a monolithic application that we're just going to lift and shift into VM or in Azure or anywhere, that's not the most efficient way of doing things. We want to make sure that we're keeping an eye on how we're spending our dollar amount when we're making certain technology choices. A technology choice could be your database choice, whatever it is. We want to make sure that we are keeping an eye on dollar amount, not saying that that should lead your architecture, but we want to make sure that we're not creating waste from spending side of things when we are trying to make these changes into our system. And we're concentrating on the important parts of the systems. If you have a simple CRUD application, at that point, what is it that's super important that you wanna tell to a person who doesn't know anything about your system? And we started kind of coalescing around this definition of architecture, and then we started to partner with Agile folks as well. And what we started out with was, hey, Agile has its place, and architecture has its place as well. So Agile is about efficiency, how to deliver your features as quickly as possible to production. And architecture is about effectiveness. Are you doing the right thing? Are we going in the right direction? So for example, I'm right now in Austin, Texas. If I have to fly to Oslo, then I would have to go east. And that's what architecture is telling me. And the map is a certain path that I'll have to fly over Atlantic to get to Oslo. And that's what the kind of architecture is about. And efficiency is, how do I get to Oslo? Am I taking a ship? Am I flying? Or things of that nature. Whatever is the most efficient way of getting to Oslo is what Agile is. And we started kind of like developing this understanding. Yes, we both have places in the software teams, and Agile is about efficiency and architecture is about effectiveness, the directional effectiveness. The refactoring then that we applied is, of course, promote the definition around ease of change, the important aspects of the systems, and then how we can concentrate on DevOps side of things, and then working with PMs very closely and repeat the message as much as possible so that anyone in the organization can easily speak to it, because we had issues where people were confused about this. So you put out newsletters, you put out different screencasts, whatever it could be, so that we know that, oh, this is what the architecture is all about. So that people know that we're not trying to just disrupt and troll their systems. We're trying to actually help and deliver their software as quickly as possible, and also make sure that it fits in the larger scheme of things. So architecture is about what makes it's all about easy, how to push your changes easily to production. What makes change? So that sounds great, but then what are some examples of making change easier to your system? So one of the examples here that, of course, this is not a laundry list of everything that's possible, but some of my favorite things here are event-based systems. So when you have systems that are communicating with each other over events, you can always take any system down and not affect the other systems, because all the requests that are coming in or all the processing that you have to do, that can be queued or put it onto the stream, things like that, so that you can process those as needed. Vertical slices, Jimmy Bogart has a fantastic talk and blog post around this. That also kind of keeps the code nicely organized in vertical slices that you can make changes to, and really the robust DevOps pipelines. So what that means is, if we are confident in our DevOps strategies, if we know that we believe in infrastructure as code practices such as infrastructure as code, we have proper monitoring in place, we have decent deployment methodologies such as Canary or blue-green or whatever that suits your service. When we have something resilient, DevOps resiliency around DevOps in place, at that point, we are confident that we can deploy our system at any time, even if it is on Friday at 5 o'clock. We can deploy our system, and if something is off, like, we can always take it back. And when we have this kind of confidence in our system, everything becomes easier to change. And these are the kinds of things that we started looking at when we started thinking, oh, what makes your systems easier to change? The next meld that we found was about documentation. Documentation sometimes gets bad rep. Like, what are we trying to do when we say documentation? Are we sitting here first up and writing everything about our service and saying, oh, I need to create all this manual about my service and how to do these things and all that, and push it out? Is it going to be just wall of text, no illustrations? We started seeing a lot of these kind of documentation. So we said, okay, we need documentation, but don't spend too much time upfront creating these documentation. It's always helpful to have these, and then we need to also think about what the documentation is going to have. Are we going to have too much text in one? Things like that. There was a lot of confusion about what effective documentation is. And we started looking at that. So first up, we started saying we need to have diagrams in our picture. So if you look at this diagram, it works. It served the purpose for the ASP.NET team at the time, or .NET team, or Microsoft teams over there. It makes sense from their perspective. But then sometimes people, they take this kind of diagram a little too far and think that, oh, I can lay down my horizontal layers just like that, and then it will make sense to somebody. But what that is that those layers are there, but then I don't know what the relationship between those layers are. So even if it worked for that team, doesn't mean it's going to work for your team from architecture standpoint. So this kind of a diagram is not very useful. It's like saying I need to make penne alla vodka, and okay, these are ingredients, and that's my architecture for my dinner. Is that useful? And what am I going to do here? Am I dipping pasta into Smirnoff vodka? Or am I just drinking vodka? I might just do that after my talk. But that's the kind of a thing where here I don't know what the relationship of all these ingredients are. So we need that. Let's look into this fantastic example that Microsoft has from microservices standpoint. It is very nicely architected. It has lots of good pieces involved. It has client apps, Xamarin apps, web apps. The backend is in Docker. It has MVC at the time. It had API gateways. All kinds of technologies are going on in this diagram, but there's just a lot of detail in here. It looks great, but then if you ask me 5 minutes later, just recreate this, I'll be really confused and I'll probably stop at like second box or something like that. So it makes sense. It looks great, but then it's very hard to keep in your mind. So how can you refactor this picture? So at that point, I've just taken out the important aspects of the picture that we just saw earlier, and then just create an abstraction on top of that saying, I have a bunch of front-end clients. Whatever they could be, the pattern is that they're going to talk to a BFF, which is backend for front-ends API, and that's going to then talk to the services behind the scenes or with gRPC or HTTP, and then those services are going to talk to each other via events or some kind of logical transport. And then if we have to go into the details of these services, you can have a different picture. You don't have to jam everything into one picture, and then the kind of value of that diagram is lost. So from that perspective, you can always create your, from individual services standpoint, a different diagram if we need to, and then depict what we need to show from that services standpoint. In here, the ordering service is talking to SQL database, and then it's generating events as we see, as it wants to talk to the other services outside of its own boundary. So the picture on the left-hand side, even though it is not incorrect, it's not very efficient from me to remember. The picture on the right-hand side, not saying that's the way to go about it, but that's one way of refactoring that picture so that I can just quickly draw it onto a piece of paper if somebody asks me, and then explain them what that system does. So with this documentation, with this in mind, the refactoring that we applied is that we want to have diagrams in our documentation. And you can, so the reason behind that is even if you have the greatest documentation, you can't force anyone to read those. So at a glance, we want to make sure that people get the idea of your system. And then that really helps from asynchronous communication standpoint. We are emphasizing on important aspect of the system instead of throwing everything into that one picture. And then using known conventions, and then creating different views as well. So you don't have to jam in the performance views, the sequence diagrams and flowcharts and whatnot and everything into one, because at that point, the diagram starts becoming something that nobody likes or nobody understands. So instead, we can create different views as needed, and don't spend this time upfront. We can always build this over time and create these different views, use known conventions that everybody understands, UML, for example, if that's what your team's comfortable with. But having these pictures into your documentation is essential so that people can understand without reading the entire description what your system is trying to do. So a book that helped me a lot, and I really liked the ideas that are in this book, The Backup Napkin, highly recommend it. Take a look at it, excellent resource. The tools that I like are the most favorite tool here that I've used over the past couple of years. It used to be called Real-Time Board. Now it's rebranded as Miro Board, which is on the left-hand side. The best part about that is working with multiple team members at a time is really good with that tool. And then there are a couple of other tools that I've used in the past as well, Diagrams.net and Lucidchart. But again, choose the tool that you like, and make sure that you have good pictures in your documentation. So that was about documentation. Then the third thing that we started seeing was people were too happy, and then when they were trying to jump onto problems, and then they were too happy to jump onto solutions, because instead of understanding what the problem is, oh, I heard microservices talk. I saw a container. I saw how to set up Kubernetes. That's something I learned yesterday. Everything has to be in cloud and serverless and whatever. And then all these buzzwords that are happening, what happens then is that we start losing the sight of what problem we're trying to solve. So early in my career, I struggled with this as well. So I have to be really conscious about and ask myself and catch myself if I'm trying to do this, that, hey, am I jumping too ahead of myself? Am I putting the cart before the horse? And understanding, right, if I have good understanding of my problem. So then the typical things that kind of contribute to premature solutioning of the problems is continuously working in synchronous fashion. We'll look into how to address those issues later. But when we are constantly asked to come together into meetings and workshops and whatever, and at that point, you're constantly working in a synchronous fashion, you're kind of like under the gun to come up with something. And then at that point, you just throw a solution at it, because in the end, you kind of like start getting fed up of these meetings, and you say, okay, let's have microservices and be done with these meetings. Lack of observability is one of the biggest things. Sometimes people say their system's slow, but then they don't have a clear data behind that saying why their system's slow, what that means. Are you talking about latency issues? What is the latency that is acceptable? Are we solving every latency problem that's out there? Or how are we trying to wrap our mind around what our system performance metrics are? So that's what the observability is. And when you don't have that, you don't have clear enough data, at that point, it becomes very difficult to justify microservices kind of a transformation, because we don't have any kind of a concrete aim to hit at. So we don't know if we're making progress or we're regressing. So that kind of a thing is really important. We started seeing that when people start jumping onto solutions without really understanding the problem, that's one of the things that's out there, that they don't have clean monitoring solutions in place. And then lack of homework and research is another thing that you want to keep yourself prepared. Whenever you're looking into certain aspects of the system, you want to make sure that you're studying around it and not coming into the problem completely cold, because at that point you kind of hurry into something without understanding what the actual problem was. So the refactoring really was, as you can imagine, pretty straightforward. Concentrate on the what of the problem. Really establish strong definition of the what we're trying to solve, because not all the time you have to solve the most difficult problem. If you can avoid it, good. At that point, you don't have to worry about that particular thing. And how will usually follow. So once you know absolutely clearly that this is what I want to solve, then how becomes very easy to answer. And if there are problems in that space, then you can always go and investigate how to find some material around that and push that forward. Test-driven development approach kind of helps from this regard, where if we can write tests about certain problems, then I know what my problem is. Not saying that that's the way of doing development. Not every problem that we have in software engineering world can be fit into the corners or four corners of test-driven development, but that's something that I see as kind of like a guiding principle from when it comes to establishing what I'm trying to solve. If I can write tests, that means I can build it. And then you can add details when it comes close to the execution time. Next up is architecture vision. If you keep addressing the symptoms, then it feels like what this cat must be feeling right now. It's trying to solve a bunch of problems, but then it's mostly addressing the symptoms, and then the progress is not really happening. So from that standpoint, let's look at an example of what that looks like. So like we talked about earlier, when somebody says my system's slow, the underlying problem could be that they're making some synchronous calls to other services, and that data doesn't change very often. This is a very real scenario that happened in our system. So if the patching symptoms that if we're looking at, then what that looks like is we're trying to make these synchronous calls faster and more reliable. Even the reliability is a good thing, but then trying to address the synchronous call feature may not be the right thing to do. We need to take a step back and think about, like, do we need to make that synchronous call? Why do I need to make that synchronous call? Do I have incorrect service boundaries? Because usually if you have to make a call into other service to do your operation, you typically tend to have a service boundary problem. And then if that's not the case, then how often that data change. So whenever that data change, can they just generate an event? Then I can just subscribe to that, and then I don't have to reach out into that other system constantly to solve my solve my issues or perform my operation. So at that point, we're really thinking from problem perspective, the root problem perspective, instead of just patching band-aids all over the place saying, oh, just make these synchronous calls faster. And then that tends to happen in in your sprint work and whatever you're trying to do at that point. Oh, it's very easy to just make this call faster and it's all good. But then that's where architecture can help, saying, yes, you can do that. However, you won't need to think about the root problems. Otherwise, you'll keep coming back to it over and over again. So where do we involve architecture in this whole process? So there is something that we tend to have typically into the workflows of the teams, which is reviewing, having architecture reviews. And at that point, that is a very kind of like a dreaded thing. When somebody says, when somebody uses the word review, it could become like, oh, anxious time. It's not, it could lead to design by committee meetings. Are we just going to troll each other? What's going to happen in these meetings? So that brings us to the smell that we saw was about the architecture reviews. These reviews were not very useful. The refactoring that we applied at that point was we need to take a little bit of a peer approach than saying architecture is something, some people that are sitting in ivory tower and trying to make, trying to tell you what the right thing is, and you don't know what that is. Instead, let's make that as a two-way process. We wanted to make that a little bit more scientific, and I'll get back to the strong opinions weekly held later on. But we wanted to make sure that we are bringing in the opinions, but then when the data that comes up, we are willing to change based on the data that's in front of us. So we wanted to be, so that's the kind of review process that we wanted to have, and kind of be empathetic to people's needs and their deadlines. Because once you come in and say, no, I want you to do certain things certain way, and then they're hearing from their product manager that, hey, I need you to push this thing in a day. And then we are saying, no, do it in a certain way. At that point, we're not being empathetic to their deadlines and the pressures that they're feeling from business. At that point, we want to understand and make sure that they're delivering the value and they're getting the most out of the whole thing and not just pushing our agenda forward. And then once we start developing this understanding, we're just peers and not somebody that is sitting over there in architecture. We're just we are your peers. We are just fellow engineers. We're similar to tech leads. At that point, once you establish that kind of confidence with the teams, the need for that kind of review kind of tapers off. And the team leads at that point kind of knew what I was going to say, and because we established that understanding with each other, and the need for the review kind of tapered off over a period of time, which was the benefit of this refactoring. Then the question becomes when to review. Are you going to come in towards the end of the process and then review? Think about Amazon. So when they were building, let's say, the checkout process, and then if they wanted to, when they wanted to make the CQRS type of process, where when you buy an item on Amazon, you're not sitting there and watching them ship the order and things like that. They say, okay, we'll get back to you. But that kind of experience was not developed just by the IT folks. They partner with the business folks as well, so that they can come to that understanding together, make the system scalable. But they have to work together on that. So you have to be involved right from the beginning, right from the user experience side of things, when you're making these important decisions about things, when you're building frameworks, when you're creating new services, what is your event structure, things like that. So when I was part of these meetings, I was able to tell the people that they needed certain information. The existing events were out there, and they had stories in their backlog saying, oh, we need to generate these events. And they were able to just remove those stories because I was able to tell them that, hey, those events exist and you don't have to worry about that. And that saved them time. So from that standpoint, when you're trying to make these important decisions, if you involve somebody that is looking at the entire picture of the jungle instead of one tree, they'll be able to help you. And that's what architecture team does. And that's when the review should happen, where when you're making these important decisions. And if we do it as a peer, then this review is more of like, hey, just double check me, please, instead of like trying to somebody just troll you at that point. That brings me to the next point, which is working culture. What is going on in this picture? Here we have 4 people locked up in a room. They're working on something, and at that point, everybody's hourly spend, the company that's spending, paying them, they're spending money on this meeting, a lot of money. That money basically is tied up in the output of what these guys are going to do. So if nothing productive happens in this meeting, that money is basically wasted. COVID-19 has changed some of this. Now we're doing all of this stuff in Zoom and WebEx or whatever, but still, the synchronous nature of these kind of meetings is very difficult to kind of like keep. It becomes very difficult to keep things efficient. Why is that? Because world just doesn't work synchronously. If you look at your fast food restaurants or anything, they're not, once you put in the order, they're not asking you to wait in order for the next order to come in. They're just they're saying, yes, we will we will serve you, but you go over there, and then the next person can pay and bring and take their order, so that they're taking orders as much as possible and asynchronously serving everybody when these things are ready. So we're taking this example from the fast food restaurants, but then if you look at the so that's how the world works when we're talking about efficiency. But when we start locking ourselves into these meetings and workshops and constant ad hoc conversations, it becomes very inefficient. And we started seeing that our calendars are always busy, and everybody's trying to talk to each other all the time. And then you become scatterbrained because you're trying to do all these things and you're working on the last problem that you heard. So we started looking at how can we solve this problem. And here's an example of AutoMapper, the open source library, and that's what we wanted to take an inspiration from. There are thousands of issues solved, 100+ contributors, not many open issues, millions of downloads. How this is working. So from that standpoint, they don't have meetings, they don't have Gitter channels, or they're not talking to each other all the time. They're not setting meetings to have like, oh, where is this gonna go in the future, things of that nature. What they have is decent documentation that's developed collaboratively, and we want to take ideas from this kind of structure. So what is the what is it that working for them? It's about communication. They're publicizing their architecture vision, where they want to go, and then it's repeated on different forums. That's what we wanted to do throughout our company, so that people have the understanding and really push for asynchrony as much as possible. And this is where the documentation also helps. So when you're setting up an email, and then in that when you're setting up a meeting, and at that point when you send a documentation to somebody saying, hey, just review this before the meeting, your meeting may just get canceled. They say, hey, the documentation looks good. I don't have any questions. Or they may say, okay, I agree with 90% of it. Let's talk about the 10% I don't understand, and have a conversation at that point. An hour meeting could be just 10 minutes. So really start pushing for that asynchronous nature of things. Build the accountability. Make sure that you're delivering the product on time, and produce screencast presentation, newsletters, things of that nature. So you're repeating what the vision is all about. And then what we're trying to do really here is that we're trying to be the change that we believe in. Instead of just saying we're the architecture, we want to push certain things certain way. We are really trying to incorporate that change in ourselves, so that we are being the leader of the company. And one of the things that we also started looking at was having a development team while you're for the architectural work as well, so that a team of volunteers can work on the tasks that are building frameworks that are looking at different things, so that you don't, the architects, if they're involved in certain high level aspects, at that point, they may not have the time to come back and code, and they can switch that position back and forth with other team members at that point, so that everybody's coding as well as trying to keep their eye on the big picture. So these rotational volunteers can do the development team, and that's what we thought that could help from the working culture standpoint. And empathy is really important because we wanted to understand that we understand the deadlines. We wanted to understand people's motives. We didn't want to become a blocker. We didn't want to become another red tape that they had to go through. We want to make sure that we're helping them meet their deadlines, not become the deadline or not become a blocker. So with that, this is what the talk's about. This is what you came here for, the role of architects. What is it that you're supposed to do from architect standpoint? So the confusion was still there about the role and the vision and things that we talked about. What are you supposed to do as an architect? Are you supposed to just code? Are you a tech lead? Are you drawing some pretty pictures? Are you doing the documentation for somebody? Are you doing a maintenance big project? Are you working with IT organization, IT part of things, or ops part of things? Are you working with business? What are you supposed to do? So first and foremost, you're going to code. So the refactoring that we applied here was that non-coding architects don't exist. We want to make sure of that. And then the reason why behind your coding is that you're sort of like trailblazing, if you can, and extracting pattern of some existing code that could be out there, and then kind of like building out the framework for for the teams to follow afterwards. So you should be coding as an architect is something that we started working very deliberately on, and that's the kind of a thing that helped us from the dev team that we just saw earlier. That architecture team used to have, that you can switch back and forth. Right? If somebody spent time doing just high level work for last 1 month, it's been a long time since they coded. Yes, we need to get them back into the coding team standpoint and have them kind of like get their hands dirty a little bit more, and then they can go back into the high level work if they're helping out other teams from that perspective. So then going back to this definition again, we wanted to do the coding work so that we are trying to set the patterns, and so that the teams don't have to exercise creativity every time they're trying to solve a problem. And the coding part has kind of like the other side of it, which is laying down the groundwork. But then how do we do that? How do we teach people when we are done with solving the problem or things like that? So pairing is a great way of doing it. If there is something that you're expert in, some people are expert at React, backend work, events, whatever it could be. So at that point, if you're working with somebody who is not experienced in that world, you can help them out by pairing. That's how I learned lots of different things, by pairing with more experienced people at the time. And ReSharper shortcuts is one of the examples that has stuck with me for over the years, that I didn't know what I was doing when I was working with ReSharper a few years, like I would say 7-8 years ago. And at that point, I worked with a very smart engineer. He showed me how to use these shortcuts effectively and kind of not break your chain of thought. And that helped me a lot immensely. So that's why I love, that's since then I kind of fell in love with pairing. But then it could be really draining if you're working, if you're pairing all the time. And if you're an introvert, it could be even more draining. So you want to pick and choose on how many problems that you're going to work on as pair. But definitely pairing is a great way of getting your hands dirty and helping the team out from code standpoint. Then high level picture is also important. You don't want to lose sight of the big picture side of things. You don't want to lose sight of the jungle, how it looks like if you're working on a particular tree, or how that tree fits into the large world. Things of that nature is very important from the big picture side of things. You want to make sure if you're building a bus, when the individual parts are being developed, you're actually coming to that. you're on the path of building that bus and not something else. That brings us to the strong opinions, loosely held type of a thing. So most of the architects on our team were experienced, and everybody was very strong-willed and strong-opinioned. At that point, when you have that, it could become sometimes contentious, and the meetings could become a little more opinionated. And whose opinion's right at that point? So if we establish this kind of refactoring kind of like motto, that strong opinions should be loosely held, what that really means is, yes, you are allowed to have your opinions, but when the data comes up that tells you otherwise, you should be willing to adapt. And that sets the example. So instead of saying I'm the right and I'm the authority, I'm saying, yes, I have some opinions, but if the data shows me that, oh, I should kind of make a compromise to my opinions and go a different way, yes, I should be doing that. And when you do that, you're being the change that you believe in. I don't know who actually said this. It's a disputed quote. Somebody's said it. I really like it. I don't know who the author is. That part is disputed. I really like the kind of like owning the change that you want to see everywhere as a leader. And you're at that point, you're doing things as you're asking other people to do. When you say, oh, you need to have effective diagrams into your documentation, okay, show them your diagram and see what that effective diagram could be. Instead of just saying, no, you should be doing that. No, let's work together, or show them your work so that they know that you have been there, and then you're solving problems as much as you're helping them solve a problem. At that point, you gain some credibility when you're working with these teams. Then one example that we had over here was about events. So one team was struggling with what the body of the event, what the property should be of our event going forward. And there was a lot of conversation happening around that. So from that standpoint, what we kind of like started settling on is that, hey, can we just create ID and timestamp and just give some name to it? Because we can always come back and add properties as we see more information going forward. So what we're trying to do here is that we're trying to help people deliver their value as quickly as possible instead of being stuck on certain things, instead of being stuck on trivia. We're saying, just put an ID and timestamp and move on, have the event, see how that looks like, put it into production, and then you can build the properties over time. And then we have done that in past. Like I've shared my code with the teams, and then at that point they were able to see how the whole process looked like, and then how the event kind of got built over time, and then we created new events based on the new information that came up, things of that nature. So we're showing them as we did things instead of just saying, oh, you should be doing certain things. Nothing turns off people than unnecessary pushing off vendors, tools, whatever your favorite thing could be. If you don't have clear definition around the problem, you're using a particular tool and that's what you like, but then the other team's using something else. Let's say you like RabbitMQ, but then the other team's using Azure Service Bus. Why does it matter? As long as they have some transport in place, it doesn't matter what kind of tool that's in place, as long as the problem's being solved. So don't try to be pushy as far as the tooling and vendors and all of that, everything around that. And we also wanted to establish that architects are not managers. They can help team members become the next leaders, but they're not going to get involved in organizational work. They're not going to go approve somebody's time off or anything like that. But they're going to help. They're going to be more of mentors, but not managers. Playing to the strength of architects. I have my own interests, and over the time that I have built some understanding about those concepts, and I like to work in them, such as events, messaging, microservices, distributed system side of things. From the backend standpoint, there could be so we had other team members who were experts in the front end side of things. So whenever we had issues that were in each other's realms, we would involve each other and take advice accordingly, instead of trying to learn something that you were not doing for last couple of years. If you haven't worked on something for last couple of years, at that point, you can say very easily that you're not an expert in that. So accept that and then move forward instead of trying to learn all the skills that are out there. Don't try to be jack of all and don't try to force that onto your teams. And that's the kind of a thing that we started implementing internally in the architecture teams, that we're trying to play to our strengths instead of trying to fit into all kinds of roles that are out there. So if you forgot about everything up to this point, what is the role of architect refactoring look like? So you're kind of fitting into these three worlds. You're coding, you're doing high-level work, and then you're making sure that you're delivering value to your business. That's what architects should be doing. So if you think about the bus analogy that we just mentioned, we talked about earlier, that architecture is making sure that you're actually delivering the bus, which is the business need. And then they're kind of like when the wheel is being developed, when the steering is being developed, and the engine is being developed, all of that stuff, like how that stuff comes together is what architecture is all about, and what the architecture should be keeping track of. That hey, when these little things that are developed, they're kind of going in the right direction. If they can apply some efficiencies along the way in those little tasks that are happening, yes, that makes sense. But then you want to, as an architect, you want to make sure that the the business value is getting delivered from the entire project, and that's what you should be doing. Then the question becomes, who should become an architect? Should excellent engineers, like the really experienced engineers, should become architects, or problem solvers, great communicators? Who should really be an architect? So when I was junior developer, like I always thought that, oh, next step in my career could be senior dev, and one day, if I keep doing the good work, that one day I'll become an architect. But that skill, architect skill, is different than being an engineer or anything similar to that, because you could have an excellent engineer, but they could not be a good architect. So it's not a natural next step of in your career. So if you're an excellent engineer, you don't necessarily have to become an architect to hit that next step. So you're excellent engineer, you're an excellent engineer. That's it. If you have interest in architecture, yes, you should become an architect, but then you should kind of like, it's not a next step in your career. You could be junior architect and still do really well. So the qualities that I have seen in really good architects are they can teach with empathy. They have good variety of experience, typically around different kinds of tools and different working cultures. They are really good at communicating and giving feedback to the teams instead of saying, oh, this is what you're doing wrong. Because if you come from that side of things, then people kind of shut you down. So instead, they help you get towards the right thing instead of telling you what you're doing wrong. And that's the kind of communication skills that these successful architects tend to have. They're not shying away from getting their hands dirty. So whether it comes to talking to business, whether it's coding or whatever it is, they're willing to solve a problem, and in any shape or form they can help. They are going to do that, and that's the kind of, and then able to handle uncertain scenarios. So this is very crucial when it comes to architecture, because you're trying to solve a business problem that was not solved before, or things of that nature. So things could get really uncertain. So you may have to build a consensus with business, with infrastructure teams, and whatever you may have. And sometimes people are not just comfortable with that, and that's totally fine. If you're not comfortable handling that kind of uncertainty, it is totally fine. You can be the expert of your art instead of trying to force yourself into this architect role. So do not consider architect as a next step in your career. Instead, it's just another kind of an engineer that you have on your team. And these architects tend to be pragmatic. Again, strong opinions loosely held. When data shows to me that, hey, there is something that's incorrect, or when the data shows, I should be thinking about something else, yes, I should be willing to make that change. And that's what these pragmatic architectures have done over the years. So parting thoughts. So what does this thing have to do with microservices at all? So microservices are about autonomy. There's a Spider-Man code in there. What does this have to do with microservices, and what happened here? So when you don't have architecture and when you don't have a strong team of architects trying to help you out in microservices transformation, and you take on this kind of a journey, that can bring in a lot of churn, and it can become really expensive exercise without that directional guidance. And that's what we saw from microservices standpoint, that, hey, when you're trying to take on a transformation exercise from your legacy applications to microservices or going to the cloud, things of that nature, when you're transforming your organization, at that point, you need to have this team in place. And we kind of learned that lesson the hard way. So what's the takeaway here? The architecture is about intentional direction. That's the why of architecture. We want to set that intentional directions. It's about the important decisions, and that's the what. How we do that, we code, we make sure that we have diagrams, we are mentoring team, we're bringing people on board onto the team so that they can understand the systems. We're bringing them with us. When should you do the architecture? Asynchronously, when the important decisions are made. And really, architecture is for people to understand your system. It's not for the kinds of a business architecture that we're talking about. They're not, any picture or any documentation that you're writing, you're not giving that to a computer system and then that's generating code and that's getting deployed. It's for people to understand. So audience for your architecture is usually people. So you want to keep in mind when you're building architecture. And then who should become architect? The mentors, the people who regularly codes, they're leaders, they are the change that they believe in. They're owning the change. They're very result oriented. They're not shying away from getting their hands dirty, whether it's when it comes to talking to business or writing the code. And of course, they have strong opinions, but they're weakly held. And if you forgot about the whole thing, and if you want to take away one thing from this, this is what I want you to take from the architect standpoint, that you're coding, you're also keeping an eye on high-level stuff, and you're setting the patterns so that people can follow afterwards, and then you're solving the business problems. And this is what I would like to take if there's one thing that I want you to take from this presentation. So with that, we have a few minutes left for questions, and this is the way that you can contact me. That's my blog, Twitter handle, and that's my GitHub. So let's see if I have questions.